So imagine, so same the top wall diagram same. So imagine only the clock. Say clock we are giving, the clock we are giving. So this is flip-flop one. So this is synchronous and this is asynchronous one. So synchronous mean at a time we will give the clock to flip-flop 1, 2, 3, 4. Asynchronous mean you will give the clock here. From this flip-flop, it will give the clock to the second flip-flop. From the and then second will be give the third, and then the clock will be here finally. Okay. So when you're giving the first pulse, at a time the clock will get for all four flip-flop. But here first pulse, first pulse. This is input, no. This how the data will send means every negative pulse. Okay. Sorry, every positive edge. Every so this is not, this is the clock. Okay, serial input we are giving. Here the clock will be given here. Yeah. So every positive edge, the data will be transferred here. Okay. So first in synchronous what happened? First, the first clock pulse, the clock is given. We're getting here. Okay, at a time. But here on the first clock pulse, you will get here, and second clock pulse you will get here. Third, fourth clock pulse, the final flip-flop will get. Okay. The synchronous, asynchronous. Synchronous is very fast than compared to asynchronous. Okay. So this is SISO, no? This is SIO, a serial in, serial out. So if you will get the input serially, and you will get the output serially. That is called SISO. So example 1010. Okay. So first clock pulse, the zero will become here. This is the, and the second clock pulse, the zero will come here, and this one will come here. Okay. And first and the third clock pulse, zero will come here. This one will come here, and zero will come here. And the fourth clock pulse, no, output will get the zero. Okay. It will be shifting. Okay. Serial will be shifting, and the one will come here, zero will come here, and finally one. Okay. So fourth clock pulse, you will get the output 0. Okay. You will get the output 0. Fifth clock pulse, you will get the 1. Sixth clock pulse, you will get the 0. And the seventh clock pulse only, you will get the output. Okay. So your output, see, one by one will come. Okay. So seventh clock pulse, you will get the output. So that is called in parallel. Okay. Next we will go for, sorry, serial in, serial out. Okay. Next we'll see the serial in, parallel. Yes, serial in, parallel. So this is the structure, okay. So input we are getting serially. Output, this is Q1, Q2, Q3, Q4, we're getting parallelly, okay. So serially we'll get the output parallelly, okay. Let's see how it works. So here we are getting the input 1110, okay. So giving this input data 1110, okay. Clock we are given here. This is the reset button, clear button, okay, no problem. So input we are giving serially, output we are getting, we get the output here. Parallel we get the output 4 bit. See, so the first clock pulse, okay. Initially here the everything will be 0, okay. Initially it will be 0 output. There's no nothing. So first clock pulse you will get 0, okay. And second clock pulse 0 will come here and 1 will be here. And third clock pulse 0 will shift here, 1 will be coming here, 1 and the fourth clock pulse will get 0, 1, 1, 1. Okay. So here we'll get fourth pulse, you will get the answer. Previously we have seen serial in, serial out. Seventh pulse only we are getting the output entirely. Here in the fourth pulse you will be getting the data 1110 you will be getting, okay. So serially giving, parallel we are getting. This is serial in, parallel out. Next we'll see parallel in, serial out, okay. So this is the parallel in, serial out. So here this is the load, okay. Here the clock is given to every clock is given to all the flip flops, okay. And here parallel we are giving, see 1, 0, 0, 1, the data giving parallel, okay. So this is the clock, okay. First clock pulse, what happened? Parallel wave, first clock pulse.
1
this
0 2 1 1 will get.
this one will come out, okay. And second clock pulse, this 0 will come out. So the input is parallel, no? Output serially will come. And third clock pulse 0. And finally, fourth pulse will get the 1. Okay. Even this
Load is
also.
load is always 1.
Yeah.
Okay.
So parallel you get, you will serially will get, okay. Fourth clock pulse you will be getting, okay. So, see, this here they have given the AND gate. Some design, this simply they have given some they will be getting 2:1 mux they will be having, okay. The design you no need, okay. That is hardware design, okay. So we want to know how it's processing, okay. Even here. Can you see this 2 mux are using here? For simplify, they're using this one AND gate. So mostly this is the correct diagram, okay. 2:1. Finally, we go for parallel. So this is people, okay, parallel. The actual clock is given here. So all clock is getting all 4 flip-flop, okay. Yeah, 1 minute. Hello? Hello? Here we giving the data, okay. Oh, yeah, I need a 1 1 0 0, okay, again. We're giving the input parallelly, okay. So the first clock pulse, the output will get 1 1 0 0, okay. And a single pulse you will get. So parallel in, parallel out is, you get the output very fast, okay. So because we are getting input here, parallel we are getting the input. So in a first single pulse, the output will get out, okay, parallel 1 0 0 will get. So parallel out is the registers to communicate very fast, okay, comparing to others. Now we'll go. So this is all synchronous. Okay, synchronous. See, all the clock is given at a time. Okay, the clock is mostly the asynchronous. You won't use any rarely will be using. Okay, so everything clock. Next we'll go for the serial communication. Okay, so normally know the communication system to send the data from the microcontroller. For that we have separate receiver and transfer pin. From that will be sending the data to the device or displays wherever you need. Okay. Okay. 1 minute. Wait. 1 minute.
Yes, sir.
First, I will open that circuit and coding and hardware. Yeah. That is the code, and we see the hardware. Okay. One minute. Uh, yeah, you use in the R6. Okay. Transfer and receiver cell. Okay. 25th and 26th pin. So you have this virtual terminal. Okay. We have placed this virtual terminal here. So transfer given to the receiver pin and receiver given to the transfer pin. Okay, that's all. This is a simple order, but anyhow, it's a serial communication register. We are going to by using the register only, we are going to send the data. Okay, how it is sending will before that I'll explain the code. So once we'll compile it. Okay, so compile is completed. Okay, now we'll explain the code. Okay. So this is a simulation, and so this is our code. So I explain the code again. So what data we are given, that will come here. So the character what we given, that will display here. Here. Now I explain the code again. Code is very simple. Just we are giving the C6 and C7. So C6 is transfer pin, C7 is the receiver pin to the virtual terminal. That's all. Okay. So include these, we are giving the include pick and a high tech compiler given, and hash define set bit. Okay. Set bit TXEN 5 and set bit SPEN 7 and set bit CRN. So we'll see what is this. Okay. So in the serial communication, we are connecting this transfer enable pin, receiver enable pin. So we'll we have to check in the register. Okay. We'll see here. So we're sending the address. We'll just check the so in serial communication. Okay, pick serial communication. These are the registers we have. Okay, TX transmit status and control register, receiver status and control register. You sort baud rate generator and you sort transmit. You sort receiver register. Okay, these are the registers. Okay. And this is the registers used for serial communication. Okay, TX SAT. This, for serial communication, we are using transmit status and control register, receive status and control register, and use of baud rate control register. And this is use of transmit register and use of receive register. Okay. So for TX80, we are using this TX80. Okay. So what does this mean? This we are making this in the
Actually, in the register, we are giving it 4 1. Yeah, in this is
yeah this, yeah, yeah. This is the fifth bit,
five
fifth,
values.
seventh, fourth. Yeah, yeah.
For
This is,
third and first.
yeah, third and first. TXEN. Here no TXEN. Zero, this 0 bit, 1 bit, 2, 3, 4, and fifth. Okay. Till now we have seen set bit giving the pin number. This is one type of, you can connect like this also. Okay. This TXEN make we are giving the define as bit means set bit. Okay. We are setting that in the fifth bit. Okay. Fifth bit is we are making enabled. That is okay. So this TXEN fifth bit is enabled. This fifth bit. No, we'll see what is in the data sheet. Fifth bit. That is here. Okay. TXN is if you enabling mean transmit enable. Okay. So the transmission is enable. This okay. You are making this enable. It is transport is enabled. Okay. Another one, SPEN. This is seventh bit. We will check in the data sheet. SPN. Where is that SPN? SPN will be the receiver, I think. Okay. It will be in the some another register. We'll see. TX SAT. It is here. So receiver status and controllers. Here it is. Okay. And receiver status controller SPN. SPN seventh bit, I think. 0, 1, 2, 3, 4. SPN will enable this. Okay. So we enable what happened? Serial port enabled configuration. C67. Okay. So this is can you see C67? Okay. So making the serial port enabled. Okay. SPN is enabled. Another one is CREN. Okay. Set bit CREN4. We'll see. It is here. Okay. So what is CREN? Fourth bit. So CREN we are making enable. If you enable what happened? Enables continuous receive. Okay. So the receiving data will be continuously to get to making this enable CREN. Here continuous receive enable bit. So you are making it enable. Okay. So that's all this register. Okay. So three registers we are using. Okay. TXEN, SPN, CREN. These registers are in the receiver status control register and transmit status and control register. Okay. The same thing I have given here explanation, code explanation. Include pic.h, HTC to header file and pic registers function. Then set bit TX and set bit ASP, set bit CRN. That defines bit position of UART control bits. It's void UART initialization. Okay, into baud rate. Okay. So we're making void UART initialization and also we initiate baud rate. Okay, baud rate I think using 9600. Serial communication, the standard no in serial communication network we will be using baud rate as 9600. And here TRISC, the TRISC we are giving 0x80. We're making seventh, making RC7 as a receiver and RC6 as output. Okay, we're making like this. Okay, so if you go as 80 means so TRISC, this is a C port. No, so this entire C port, you are making this output and input. Okay, transmitter, output, and this is a input receiver. And here we're using TXSAT. Okay, we'll check this TXSAT. This is a register we are making as SPIT1 and TXENS, enabling transmit and synchronous at 8-bit mode. Okay, so we'll check this TXAT.
So we are moving the 5 bit and between the 6.
Yes.
Okay. So in the 5th bit we set as 1.
So this is wrong. This is the register TXSSTA, transmit status and control register. This is this one. What are we doing? Set bit TXEN, enabling the TXEN. Okay. Yeah, the TXEN. So if we setting this bit, so what happened? Transmit is enabled. Okay. To enable the transmit, we are enabling this bit, making 1. So this TXSAT transmit status register in this set bit 5 TX enabling the transmitter. Okay. So again, another is receive status register. receive status register. Okay. Here we are making SPEN to enable. We'll see this register RCSAT will be the next register. Here no. Receive status and the control register. Here SPN. So we are enabling that. Okay. Enabling this SPN and CRN both. SPN making one, SPN set bit. Okay. Enabling the serial port continuous receive. You see what is CP. CP here. Okay. CPN. This last bit, seventh bit. Okay. CPN. We are CPN means serial port enabled bit. If you are enabling means serial port enabled. Configures RC7 and DT and RC6 as transmit and pin as serial port pin. Will change it. Okay. For this configuration, we are making enabling it. And CRN. Okay. That we are setting that bit. Okay. What is CRN? Here is CRN. Okay. CRN continuous receive enable bit. So make enables continuous receive. Okay. We are making that CRN. So receive status register. We are making seventh bit and fourth enabling. Okay. And this is another register. Yes. Yeah, this is SP by U. SP by means U sort baud rate generator. Okay. So they generate the baud rate frequency. That is the inbuilt baud rate formula. Okay. Signal baud rate equal to FOSC divided 4x plus 1. So this FOSC normally our frequency 11.0592. This is a normal atmel atmel they will be using. Okay. And this is a baud rate. Baud rate equal to 11.0592 divided by 64 by 6 plus. So we are generating the baud rate 9600 for this megahertz. Okay. And set the baud rate for 20 megahertz. And that is a formula. Yes, formula set the baud rate on system clock 20 megahertz and desired baud rate 9600. The next is void your transmit character. Okay. So why here you're using while TXIF equal to 0. Okay. We'll see what is the TXIF. 1 minute, we'll check this. 1 minute, wait.
I think, sir, receiver will wait for the characteristics so while loop, and the receiver will clear after that. When it is received, it getting the while loop has come out. Then it
For
gets
that only.
cleared, I guess. Yeah. Then we are
That's
storing into that list.
that's only. That clearing. Clear the transmit interrupt flag and transmit load character. Okay. For character, we are getting this. So waits until TX and clear the flag and send the character. Character you are receiver character. Okay.
The TX if will get one, so it come out.
Come out.
Then again we are making as a 0,
Yeah.
and we are putting that in CH.
Yes. Yes. And wait until TX is ready. Clear the flag and send the character. Same here. While RCF is 0, wait until character is received. Okay. So RCFF is getting clear receive flag at 0. And return to RC REG, return received character. It waits until the character is received and clear the flags and return the received character. In the main going, okay. So here the character, okay. Character IE in the A. So we are giving the string, okay, technology innovation technology hub. Again the character. So we are in the UART initialization, we are giving the baud rate as 9600. So the A to string to send, okay. And UART initialization 9600. Initialization UART for 9600 bits per minute for communication. And this for
So
loop.
we are specifically allocating for this, sir.
Yeah, this specific allocating.
From the 20 megahertz.
Yeah. Mostly every normal communication will be using 9600. Even for in networking
Do
also.
we okay? Do we using any like library function? Okay, this function will be created in the top. Okay.
The header itself. This standard is 9600.
No, this function UART init where we
Yeah.
created
No,
in the
this,
top itself. Created.
this is function we given.
Yeah, this function where we created it is in the library or
It is in the library.
okay.
No, on the your transmit character sends character by the string, okay. And this loop through the string it sends to one by one, okay. So one by one it will send. And the wait ch you are receive character wait and receive one character, and your transmit character send the same character to by echo, okay.
This function can't we create our own, sir?
Which one?
This UART init, UART
Let's create our own.
TX.
Yeah. when it receiving 1 minute. Can you see the screen? Now 1 minute. 1 minute wait. This virtual template will display here. Okay. This is one type of telecommunication. Okay. Yeah. 1 minute. I think you have seen. I think you have seen this. No, this is normal max 3232. And this is even this is the communication we will be using. Okay, transferring the data. Okay, receiver and transmitter. Okay, of the port we will be using sending this data. And this is also IC. Okay, max 3232. So this is one type of driver. Okay, the receiving driver. Driver will be using this. I say everyone this board not used. I explain it later. Okay, about this. Oh. Same this you sort you sort will be using this pins. Okay, in the IC will be using the transfer pin and receiver pin. Okay, this is the transfer receiver pin. But in the I2C we will be using this SL serial clock serial data. Okay, only this two pin will be using. For serial communication we will be using this pins. For I2C we will be using this pin. Okay, so before that I'll show you that another thing. Okay, motor. Okay, motor control. So all I L293D. Have you learned that driver AC? Previously, I think you didn't heard no. So now I'll tell you what is the use of the L293 driver AC. Okay. So, yeah, driver ACs will be for the uh, larger displays. Okay, multiplexing displays, small multiplex displays they won't be used. 16 or 17 for that for SP they will be using the driver ACs. Okay. This is a sun mark, cyan mark displays. Okay. Further, directly we can't give from the microcontroller. We will be using the driver from the driver AC. It will be drive displays. Okay. Even for the controlling the motor, we'll having separate driver AC. But I'll show you that. One minute, I'll show you. We'll see it. Okay. First, I'll show the hardware. Okay. Okay, this is the L29 3D. This is the driver receiver. Okay. OC will be using the driver OC for the motors, even for the multiplexer 7 segment, and even for the serial communication, because the higher part of the transmission, no, directly we can't use from microcontroller. For something we need a driver AC. Okay. Without using driver AC, we can't directly give the connections to the output. Maybe some small uh, uh, outputs we can give it. Some needs the driver. Okay, relays, motors, and LCDs displays. Okay, and the transmission higher bit transmissions. For and all, we need the driver AC. Okay, so till now, I think I never teach about the driver ACs. Okay, you learned about the driver AC. Anyone till now? Previously, you have learned about driver AC. What is the use of driver AC?
No, but I know idea
Used
about
to
this.
control them.
Yeah, yeah,
Yeah, there are two inputs, and
yeah,
that
yeah. No, no,
enable
no.
pin will be one or a zero. That
Yeah.
it,
Okay, any of you know, but any of fathers, I'll tell you. Okay, what is the use of? See, this is 8 pin. First, I'll.
உனக்கு
Which one? Which one? So we are void initiating and hash define DC motor. Okay. Port C. Port C is connected to the DC motor. Not DC motor. We're giving a variable name. Okay. For port C, we are using a variable name as DC motor. Okay. For this port C. Again, void main. This you're using infinity loop. Okay. So what are you using? We are using a tris C. We're making this port as output. Okay. Yeah, making this port as output. Now we are using this DC motor. The DC motor giving the 0x05. This is to motor to forward and motor to reverse. Okay. This X code how it works in the driver. I'll tell you. Okay. Okay. This is the L293D. This IC. Okay. This is the structure of the IC. Okay. L293D is a typical motor driver IC which allows motor drive either direction. Okay. It's a 16-pin IC which can control set to DC motors simultaneously any directions. Then this no. So pin 2 and pin 7. It is this pin this pin 2 and pin 7 are the input. Okay. So in the pin 2 we are giving 1 and pin 7 we are giving 0. So 1 0 we giving 1 0, pin 2 1 and because these are two input, no input 1 input 2. We are giving 1 and 0 means the motor will be uh, run in the forward direction. And in the same pin we are giving pin 2 we are giving 0 and pin 7 we are giving 1 means motor will run in the anti-clockwise direction. Okay. So pin 1 0 clockwise direction and pin 0 1 is anti-clockwise direction. And if you give 2 and pin 7 0 0 means it won't rotate, it will be ideal. Okay. Same you are giving pin 2 and pin 7 1 1, then it will be ideal. So it won't run. Okay. So in this IC we can use two load. Okay. Two inputs we have, input 1, input 2. Second pin and 7 pin for one input and input 1 and 10th pin input 3, 10th pin and 15th pin input 4. That is for another motor. Okay. So this is output. Third pin and Sixth pin we use for one motor, and 11th pin and 14th pin we can use for another motor. Okay. In the diagram you can see it. Okay. It says in Proteus only what are the pins needed that will be there. Okay. This from the port C we are giving, if you giving 0, 1 means we will run forward. If you give 1, 0 means the motor will reverse. Okay. But here we are using two motors. For first motor we are giving input 1, input 2, second pin and 7th pin. And for second motor we are using 10th pin and 15th pin for second motor. So out 1, out 2 given to the first motor. From the out 3 on the out 4. Third and sixth pin is for output. 11th and 14th pin for another motor. Okay. So in the coding, we are giving 0x05. 05 means it will be forward directions. Okay. Why is 05 means we are using two motors now. That's right. I'll teach here.
RC0 and RC2.
Yeah, yeah. So this is the register. Okay. So this is a C port. So in this C port, we are using only C0, C1, C2, C3. Okay. So input we have to go 1010. Remaining we are not used. Okay. I think 0. We are using only use this port. This port. So 1010. This LSB using in this MSB we are not using 0. Okay. So 1010. If this from the microcontroller we are giving 10 means 1010 is what? 5 no. So 0x. So the MSB is 0 and this is 5. So this X code is given here 1010. Okay, what happened? So if you're giving second pin 1 and seventh pin 6, what happened? Again, the input we are giving 10 means motor will run forward. Here no. Second pin 1, second pin 1 and the seventh pin 0, 10. So for two input we are giving 1010. If you use means what? Motor will run in clockwise direction. Okay. So 0x05, 1010 giving. So what happens? Motor will run forward action. It's the same thing. Okay. So my motor want to run in the reverse direction. Zero one reverse. So here you have to do we're going 0 1 0 1. Then reverse direction. Here. Pin 20 and pin 71. If you go sorry, pin 20 and pin 71 we are giving means it is anti-clockwise direction. Okay. So 8 plus 1 how much? 8 plus 1 10. So A. Okay. So 0x 0 here it is 0. Okay. 0A. In the coding again 0A. We are given 0A. Alternating 0101 and 1010. So motor runners anti-clockwise direction. Okay, this is the thing we have given. Okay, so but directly from the microcontroller we can't give to the motor by using the driver AC. From the this is exclusively for only for the motor driver AC, DC motor driver AC. Okay, and also we can use this for stepper motor also. Stepper. Okay, stepper motor also we can use it. Later on I'll tell now. Yeah. So multiple driver is there even for the LCD displays, not for 7 segment, others. So power rating with high will we're using that. So some outputs without driver we can use it. By using the drivers only we can control it. Okay. This is one example. So that's why I given. So I given the delay no. As per the delay, it is running forward direction and then running the reverse direction. The real time as per our requirement, we can use this motor. Okay. In the next class, I'll show by using the push button, interrupt push button, I'll how to control it. Okay. So if no time, we have to will take more time by using push button. Okay. By using interrupt, I tell you how to use this controlling the load. Okay.
Okay.
Yeah, I'll send this example codes and simulation to your
Send
group.
the both.
Okay. Okay, both I'll send. Also Monday we'll see the I2C also. So tell me the attendance. Next.
భాగస్వామ్యం.
Next, anyone?
గురువేల్.
Next. Yogesh. So okay. Thank you. We'll meet on Monday. Okay.
థ్యాంక్ యూ సార్.
Thank you.